All right, to start at the top of the page, I want you to do something first. Can you do me a favor? Can you sketch y equals to x squared at the very top? I think it's a very easy thing that everyone should know how to do. Y equals to x squared. Okay? Should take you no more than 2 seconds to do it. Y equals to x squared. Okay, so everyone should be able to draw something like this. Yes? Yes, 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 yes. All right, now, so the reason I asked you to draw this because I want this to serve as your anchor. You knew this. This is nothing new. You knew this from algebra 1, I think, right? X squared, quadratic, algebra 1. So, so when x is squared, it's a vertical parabola. When x is squared, it's a vertical parabola. It's nothing new, okay? And it's opening up. Why? Why is it opening up? Because what? The A, right? It's positive. So if you want the parabola to open down, what has to change? The sign, right? It's gonna be negative, like to open down. So now, if you know this, then let's think about this one. What would this look like? What is x equals to y squared? It will still be a parabola, but it will be opening to the right. Okay. And if I wanted to open to the left, make it negative, right? So I want you to know like something easy first before we dive into those conversion stuff. Okay. And now here's another thing. Let's see how many of you still know this. Can you write down the vertex form of quadratic equation? If you are taking the SAT soon, you have to know this. Okay. What's the vertex form of a quadratic equation? What is it? Y equals to A times X minus H squared plus K. Okay, now we will start from here. Okay, we'll get to the standard form, but I want you all to start from the vertex form. And of course, if you're taking the SAT, you really need to know this because it will be on there. They may or may not show it so explicitly, but you should know the vertex form. You should know how to get to the vertex form for your SAT and also for your calculus. Now we are going to change from the vertex form to the standard form. So it's easy. It's very easy. The first thing is let's get X and Y on each side and let's clean up the right-hand side. Let's not have the K on the right. So we say, all right, sure, let's go ahead and subtract K first. Okay, let's go ahead and subtract K. And then, now that's one new piece of information. Now we used to say A value, right? Now today, I'm going to see something. A, it's also known as 1 over 4P. And I will tell you what the P is for in a second, but that's a new piece of information. Okay. And the other thing is we don't quite like fractions, so let's go ahead and multiply the 4P to the other side. So 4P times Y minus K, it's equal to X minus H squared. And this is your standard form. Now, of course, this will be a standard form for a vertical parabola. If it is horizontal, it would be 4P X minus H equals to Y minus K squared. Okay, I don't mind if you flip the left and right. Okay, I don't mind if you put the square on the left, That's fine, okay? But you have to have this form. All right, so that's something new. Okay, so if you happen to forget, well, just get it from the vertex form. If you don't know the vertex form, then know it. So that's standard form. We'll take a look at that in a moment. Let me duplicate it so that we can have some reference. Okay, as we do this part A. So for part A, what kind of parabola is it? Is it vertical or is it horizontal? It is. It has to be vertical because the square is on the x, right? So what we do, it's very simple. We just keep the x on the left and everything else on the right. And then we do the old thing. We complete the square. So we say, all right, plus 4 on the left, plus 4 on the right. Therefore, we have x plus 2 squared. Oops, not yet. So on the right, we have this, okay? So we have x plus 2 squared equals to negative 12y plus 36. And if you look at the standard form, we always have a coefficient of 1 in front of y. So we have to factor out the 12, and negative 12, sorry. So be very careful when you factor out the negative 12, the sign, okay? Pay attention to the sign. So that would be your standard form equation. So you know that it is a vertical parabola, and because the p or 4p is equal to negative 12, the negative here tells you that this vertical parabola will be opening down. Okay, so I'm just gonna have a little sketch of a parabola opening down just to remind myself so that I don't go to the wrong way, the wrong direction. So my vertex, well, the way to extract, it's just like how you extract your center in the past, but we don't have a center this time, we just have a vertex. Negative 2 comma 3, negative 2 comma 3 right here. So that's the vertex, and in my mind I know it's going to point down, but before you draw it, before you draw anything, we have a few more things to take care. Now 4p, it's negative 12. Now we care about a couple of things. We care about the absolute p-value. What would be the absolute p-value here? It will be 3. And we also care about the absolute 4p value, which is 12. Now, these two pieces of information will be very crucial in our construction of the parabola. Because, well, we don't have the A, B, and C nowadays for this topic. So we need our p-value. How do we get our focus? P units away. Okay. P units away. So if the absolute value of P is 3, so in this case, 3 units away from the vertex is your focus. And then we also have something called the lattice rectum, which is the line that passes through the focus. And again, we don't have B or A, so the length of the lattice rectum is the absolute value of 4p. In this case, that would be 12. And that would be crucial because we are going to make some points based on this length right here. So if the length is 12, and this is a line that cuts through the focus, so, well, if the whole length is 12, that means on each side of the focus, there must be 6 units. So 6 units to the left of the focus and 6 units to the right of the focus. That would be your point of the parabola. And that's how you draw your, well, actually I should give a little bit more effort. Okay, so that's your parabola. What is the axis of symmetry? X equals to -2. Now, there are people, there are students, try to memorize everything, and they memorize it in a very ineffective way. They try to memorize what to do, but then I would say maybe you want to take a moment to understand the meaning of the term first. Like when we say axis of symmetry, like can you see the symmetry on the parabola? Can you see that there's a symmetry right here? Well, if you can see it, that is your axis of symmetry. Then you just need to extract the x value here. That's your axis of symmetry. You don't need to memorize anything for the axis of symmetry. All right, now, that's another thing that's new here too, the directrix. That's new. What's the directrix? Well, the directrix, it's also p units away from the vertex, but it's the other way. And the directrix, it's a line. Okay, and you use a dashed line to draw this directrix. In this case, the directrix would be y equals to 6. I think a worthy question to ask is that what the heck is a directrix? Yeah, what is a directrix? So if you go to Google and if you quickly search what a directrix is, so I searched what directrix is, and there are a few diagrams, and if you click the diagram, what you see is this. The reason why we have a line of directrix is that any point on the directrix, okay, if you go straight up to the parabola, okay, that distance from the directrix to the parabola is the same distance from the parabola to the focus. It's very magical that we don't care a lot after all. So it's just for this topic, okay? It's just for this topic. We will not talk about directrix after this unit. In calculus, I've never seen directrix at all. So it's a term. So it's a term. So here, okay, we learned something new here. We don't have the ABC values anymore, but we have a P value. So make sure you know that how the P value it's important, it's significant here. I think I should also label something here too, that this distance here is absolute value of 4P. Okay, that distance right here of the lattice rectum. Okay, this is the lattice rectum. It's absolute value of 4P. Okay, so questions? Good.